The Industrial Revolution was a changeover to new industrial processes from somewhere in 1760 to sometime between 1820 and 1840. This evolution comprised of moving from manufacturing goods with hands to machineries, bettered efficacy of water power, manufacturing of new chemicals and producing iron through new ways, usage of steam power, the advancement of machine tools and the upsurge of the factories. In terms of employment, fabrics were the leading trade of the Industrial Revolution. Keeping in mind the value of production and the principle invested, the fabric industry was the first to use contemporary manufacturing ways. The foundation of the Industrial Revolution was laid in the United Kingdom, and some of the most significant technical inventions were from Britain. The revolution took place in 1815 and continued to the next century. The steam power was a breakthrough this revolution. The idea was mainly to pump out water from the English iron and coal mines. This artificial power rapidly converted to driving force for the coming century. In years to come, this invention was used in textile production, mining, iron smelting and many other industrial quests. The beginning of 19th century witnessed yet another invention after the steam engine: railroads. The steam engines also directed the way to invention of first steamboats and then steamships that made regular journeys across the ocean, radically decreasing the time taken to travel overseas. There are many factors that can be taken into consideration which led to Industrial Revolution. However, there are three main factors to which this industrial age could be entrenched to: steam, iron and coal. Coal was used to fire the steam engines and was produced in huge quantities in England. These mechanical devices and other machines were designed and forged out of iron. The vagaries that started in the Industrial Revolution never actually came to an end. The roots of this revolution dated back to 1,000 years ago. History speaks of Iron Age, which began in 1,000 years before Christ. When men carved weapons and tools of iron, the Iron Age sustains as we are still dependent on this essential metal, and the effects of Industrial Revolution persist to amend modern economies, creating undulations in the industrialized world. The Industrial Revolution symbols a key turn-off in history. Nearly every facet of day-to-day life was swayed in some way. In specific, average revenue and populace began to display extraordinary constant progress. Many economists say that the main effect of the Industrial Revolution was that the standard of living for the overall people arose steadily for the first time in history, though others say that it did not begin to evocatively progress till the late 19th and 20th centuries. At about the same time the Industrial Revolution was happening, Britain was experiencing an agricultural revolution which aided to expand the standard of living. In early 19th century, production of textile in a mechanized way spread from Great Britain to Europe, France being the home to most important centres. An important iron manufacturing centre established in Belgium, industrialization spread fast throughout the world since its inception. The exact start and end date of the Industrial Revolution is still argued by the historians, as is the stride of social and economic change. GDP per capita was approximately steady prior to the Industrial Revolution and the advent of the modern capitalist economy, whereas the capitalist economies witnessed an age of per capita economic growth in the capitalist economies in the age of Industrial Revolution. Beginning of Industrial Revolution has been labelled as the most significant occurrence in the history of mankind since the domestication of plants and animals. Between the shifting years of 1840 and 1870, when technology and economy progressed rapidly, embracing steam transport and mass production of machine tools and the usage of machines in factories that were powered by steam, the First Industrial Revolution evolved to Second Industrial Revolution. Where it all started. There are many countries who have been active participants in the Industrial Revolution. However, it all started with Great Britain, which then slowly moved to America, Europe and the rest of the continent. Great Britain heads the way. Earlier, the English had become one of the most powerful nations of the world. Early in 18th century overseas trade made Britain a wealthy country. During the many wars that happened in the century, particularly the 7 Years' War, Britain extended their control over many colonies across the seas. England's main rival France lost control of Canada and India to the English in the mid-century. The English navy commanded powerful trading ships spread across the world. The English faced a lot of problems on various fronts. Population of British Isles multiplied quickly, which led to a shortage of wood and cloth. People replaced wood for coal and used it in place of wood to cook, heat the homes, for smelting and blacksmithing. Huge demands for coal led to extensive mining. Miners dug deep to supply the people with coal, and to find coal in the surface was no more possible. Deep mines posed a problem because water seeped in them and something needed to be done to pump out the water from the mines. The solution was soon invented: steam-powered pumps. These machines forced water out of the flooded coal mines, making it mineable again. Earlier, the English used wood to smelt iron, which they soon replaced with coal. First, they used charcoal to heat iron and to remove its carbon impurities, but later on, in the 18th century, these smelting industries started using coke, which was a greyish, hard substance produced when soft coal was heated in an airtight oven which removed the coke gas and coal tar as the fuel for smelting iron. This expanded the business of coal mining in England. Since Middle Ages, England was home to wool trade. The Englishmen raised sheep in their farms and spun thread, which was later spun into woolen clothes and garments. The growing population now required clothes, and to overcome this shortage, many new machines took over the old system of cloth production. When the English expanded their trade to Egypt and India, they were introduced to a new type of material: cotton. There were thousands of women who worked to spin wool, and now cotton, but since the requirement was too much, they lagged behind in the mass production. The old ways of using the spinning wheel could not keep up with the demand. There were two things required: more quantity and better quality, for which two things were required: good machines and to build faster. These setups required bigger space and bigger facilities, which led to the establishment of factories, which was also the result of Industrial Revolution. Revolution in metal industry. Once coal replaced wood and other types of natural fuels, there came about a drastic revolution in the metal industries. When given a certain amount of heat, coal needed less labour in mining than chopping wood and then turning it to charcoal. Coal was naturally obtainable in plentiful. Coal gained its importance in 1678 when Sir Clement Clerk and a few other inventors started using it in reverberatory furnaces called cupolas. These cupolas were operated by controlling flames on the charcoal, coke mixture and ore, which reduced the oxide to metal. The advantage of using this mechanism was that the impurities like sulfur ash did not combine with the metal. The same technology was later applied to smelt lead and copper in 1678 and 1687 respectively. Later in 1709, Abraham Darby successfully fueled his blast furnaces at Coldbrookdale with coke. The coke iron that was manufactured by him was used to make cast iron products like kettles and pots. He had patented his cast and hence had an advantage over his rivals because the pots Darby manufactured were thinner and cheaper compared to his competitors' products. Darby's sons established two furnaces at Ketley and Horsehay, who produced bar iron in the mid-1750s. Coke pig iron was now cheaper than charcoal pig iron, and since iron cast was also cheap and was available in plenty, it was started to be used as materials to build new structures like the Iron Bridge of 1778. Till now, the ironsmiths still use the finery forges to make daily consumer products from the bar iron. But with the time, new procedures were developed and implemented in the years to come. The earlier methods were known as potting and stamping, which were later modified by Henry Court's puddling process. Court made two important iron-producing processes. In 1783, he developed the rolling process, and in 1784, he made the puddling process. In order to consolidate wrought iron and remove scum, hammering was replaced by rolling, which was about 15 times faster than hammering. Initially, the rolling mills were used to make sheets, but later on the process was used to roll structural shapes like rails and angles. When pig iron was decarburized using slow oxidation and iron ore was used as a source of oxygen as it was stirred manually with the help of a long rod, the process was known as puddling. Decarburized iron has higher melting point compared to cast iron, so it was scraped into blobs by the puddler, and once the blob was big enough, the puddler removed it. It was not easy to puddle in such high temperatures in the reverberatory furnace, and there were only some puddlers who made it to the age of 40. Puddling was used till the 19th century, when steel was slowly taking the place of iron. The process of puddling could never be mechanized as it needed the skills of a human to sense the iron blobs. Till mid-17th century, the British iron manufacturers used substantial quantities of iron that was imported to add on the local provisions, which mostly came from Sweden and Russia. Later, from the 1785, they stopped importing iron from the countries thanks to their iron-making technology and began exporting wrought iron products to customers and bar iron to other countries. The most vital development of the 19th century was the hot blast, which was made and patented by James Beaumont Nielsen. The process saved energy in the process of making pig iron. The combustion air was preheated by using waste exhaust heat, so the quantity of fuel required to make 1 unit of pig iron was decreased by around 1/3 if coal was using, and 2/3 if coke was used. The effectiveness was more every time the technology was bettered. Hot blast kept the temperatures of the furnaces high and helped in growing their capacity. The lesser the coke or coal was used, the fewer impurities was present in the pig iron. This also meant that anthracite or lower quality of coal could be used in places where coking could not be done, or the process was too expensive to be performed. Nevertheless, by the end of the 19th century, the transportation costs fell extensively. About 20 years before the Industrial Revolution laid its foundations, the production of steel, an expensive commodity then, was improved and used to make products like springs and cutting-edge tools, as iron couldn't be used to make such commodities. In 1740s, Benjamin Huntsman developed a crucible steel technique which used blister steel as raw material made by the cementation process. Inexpensive steel and iron helped many industries like nails, wire, hinges and hardware products. Improvement in the machine tools made it easy to work with iron, because of which the metal was used in making of machines and engine industries. Revolution in the textiles. For years, England was the spearhead in the making and extension of Industrial Revolution. There are some noteworthy reasons to why there was a sudden shift of England, from being dependent on agriculture to relying increasingly on industrialization. For example, in the 1700s, Britain was led by parliamentarians and ministers who reacted compassionately to commerce, trade and industrial expansion. Their lands were rich with raw materials such as coal and iron ore, and human labour was cheap. There were many financial institutions like banks and lending houses which helped in raising capital to purchase steam engines, make factories, construct mills and employ workers. Moreover, England had many overseas markets. They had to be ready with products which could be used for trading like coal, iron, textiles or any other things. One of the causes of Industrial Revolution was originated in the textile industry. When cotton material was introduced to England in 1600s, it completely changed the way of producing cotton thread and cotton materials. There were a series of improvements and creations that brought about the change. An English weaver, John Kay from Lancashire, invented the flying shuttle in 1733, in which a hand loom could be operated by a single person instead of two. However, the mass was not quite happy with the invention, as they thought the new machine could leave many people unemployed. The angry crowd attacked Kay's home and demolished it. Kay's flying shuttle took time to gain recognition, which however helped to improve the production speed of a single weaver, but the one-man loom needed thread from 4 to 5 spinners to keep a loom worker busy. Within years, in 1765, a carpenter from Lancashire, James Hargreaves, invented a spinning machine which could spin 8 threads at a time. He named the machine Jenny, after his wife. He patented his new invention in 1770. Slowly, the number of threads which a spinning machine could produce increased to 100. However, the cloth workers' reception of such new inventions was slow. As a matter of fact, Hargreaves too faced the same consequences as Kay when his house was attacked and his newly invented spinning jenny was burned. Cotton thread industry was transformed by these wonderful devices. The spinners were now spinning around 20,000 spinning jennies by 1778. This machine cut down the working hours which was spent in spinning thread and yarn. Earlier, one had to work for 1,000 hours to make about 22 pounds of cotton thread, whereas the spinning jenny brought down the spinning hours to 400, and with further improvements and creations it came down to just 20 hours. Lancashire seemed to be home to many inventors. In 1769, Richard Arkwright, a barber from the same place, held patent to water frame. These rollers were powered by water which were used with spindles to produce coarse but strong thread. Some years later, Samuel Crompton, a tinkerer also from Lancashire, produced fine and strong cotton thread by combining Hargreaves' spinning jenny and Arkwright's water frame and called it spinning mule. These machines brought about a revolution in the textile industry to an extent that the English, who were spinning about 8 million pounds of thread in 1770, started spinning 37 million pounds of cotton by 1790. The quantity kept increasing, and in 1815 the English reached the 100 million pound mark, and by 1850 the English weavers boasted of spinning around 250 billion pounds of cotton. Edmund Cartwright was aware that once Arkwright's patent expired, the demand for spun cotton would go up, and leading to a shortage of weavers, he invented a power loom in 1784, which he patented in 1785. Edmund Cartwright had built 2 factories, both of which were destroyed by his workers and burned down by his workers and angry mob respectively. Cartwright's machine design had many faults, especially thread breaks, and in 1813 Samuel Horrocks patented a better loom which proved to be fairly good and was successful too. Richard Roberts bettered his loom in 1822, and Roberts, Hill and Company manufactured these looms in huge numbers. The increasing demand for cotton was a good prospect for the planters of southern United States if they could remove the seed with ease. Keeping this in mind, Eli Whitney invented the economical cotton gin. What a woman could do in 2 months, cotton gin did in a day. More inventors effectively improved the steps required in spinning, increasing the supply of yarn. These inventions and innovations were supplements for the weaving industry which helped them to grow and flourish. The final product or the outcome of a labourer increased intensely. Although Richard Arkwright is accredited with many creations, they were truly developed by John Kay and Thomas Hayes. Arkwright was an entrepreneur who fostered these inventors, patented the concepts, funded the creativities and sheltered these machines. He established a cotton mill that brought together all the processes of production under one roof, and it was he who developed the use of horsepower and then water power simultaneously, which mechanized the industry of cotton. Back in 19th century, Manchester was known as Cottonpolis because of many textile industries in the city. Revolution in steam power. What drove the industrialization age was primarily exploiting a natural source of power, steam. The innovative minds of the ancient ages also understood the marvelous power of steam. In Anno Domini 60, a Greek tinkerer, Hero of Alexandria, made a small machine that was made up of metal spheres with sprouting jets and was mounted on center shaft. When the water present in the sphere was heated using fire, the ball moved when steam spurted out of the jets. It cannot be called a perfect device, as it did not serve any cause. It was more like a toy, and the rudimentary device was named Aeolopia. Many years later, the device was built again, but this time it was for a specific purpose. Increased demands of coal required the English to dig deeper into mines, which drove water in them. In order to get rid of this problem, these devices were used to pump out the water. Deeper the mines, more acute the problem became. Earlier, when the water problems were closer to the Earth's surface, was solved by using horse gins. Gin was short for engine. The method involved horses who walked in circles with a huge drum tied to a pulley and a bucket. Since the mines were now deep, the horse gins could not solve this problematic situation. A new technology was required. Thomas Savery, a British citizen, came to the rescue for this problem. In 1698, he invented a low-power steam engine which functioned as a pump. The water pump, that was branded by the name Miner's Friend, produced around 1 horsepower and was put to work for many water-related works and coal mines. For minor horsepower ranges-related works, Savery's pump was very cost-effective but was susceptible to explosion of its boiler for large horsepower ranges. These pumps sustained in the market till late in the 18th century, till an English metal and iron salesman, Thomas Newcomen, built his piston steam engine in 1712 in the Midlands, near Dudley Castle, near Coalbrookdale. The engines were productively used in the deep mines, which were blocked by water. Since these engines were kept on surface, they were huge in sizes, needed a lot of investment to build, and produced 5 horsepower. If we look at the machine from our perspective, it was incompetent as per our modern standards, but if they were set on pit heads, where the coal was cheap, it gave way deep coal mining. Despite a few disadvantages, the engines of Newcomen were easy to maintain and dependable too. Hence, they continued to give their services to the coal mines till early 19th century. By the time Newcomen died, his work spread far and wide, beginning with Hungary, Austria, Sweden and Germany. According to the records, an aggregate of 110 engines were being built by 1733 out of the joint patent expired, 14 of which were in abroad. Within years, an engineer, John Smeaton, built many large and improved engines, and the total number of engines built reached to 1,454 by 1800. James Watt, from Scotland, brought about an essential variation in the operating principles. Englishman Matthew Boulton had almost perfected his steam engine by 1778, which assimilated many essential enhancements. Of it, the most noticeable thing was that the upper part of the cylinder was sealed off, enabling the low-pressure steam engine to drive the top of the piston in place of the atmosphere. There was a separate chamber for condenser and the usage of a steam jacket. The cooling water, which was inserted right into the cylinder in order to cool it and was used to waste steam, was removed because of a separate condenser. The inclusion of a steam jacket retained the steam from condensing in the cylinder, which also improved the competence of the engine. The bettered ways and processes that had now been integrated in the steam engine by Watts and Boulton used just 20 to 25% as much coal per horsepower per hour as compared to Newcomen's engine. Watts and Boulton manufactured such engines in the Soho foundry, which was established in 1795. By 1800, Watts' steam engine could straightaway drive the rotary machinery of a mill or a factory. It had been completely transformed in a double-acting rotative type. Watts' engines were profitable and popular. Their company, Boulton and Wath, had made 496 engines, 24 serving blast furnaces, 164 driving pumps, and 308 powering mill machinery. Almost all the engines produced 5 to 10 horsepower. Many metal machinery tools played an important role in making these powerful engines. Engines planning, milling, lathe and shaping machines were power-driven by these engines, which enabled the accurate cutting of the metal parts. The design of the steam engine until the 1800 was based on beam engine, made as an essential part of a brick or stone engine house, but soon many different outlines of a self-sufficient rotative engine was produced like the table engine. In the beginning of the 19th century, Richard Trevithick, a Cornish engineer, along with an American, Oliver Evans, built non-condensing high-pressure steam engines, fatiguing against the atmosphere. The engines were solid enough and could work on rail locomotives, mobile road and steamboats. Revolution in machine tools. The many machines that were being developed increasingly required machinery to cut metal parts. Some small tools were developed earlier by the watch and other small instrument repairs. Before machine tools were invented, there were many hand tools that were in use like files, scrapers, hammers, chisels and saws. Metal was hardly used, and the wood products would split or crack with changes in weather. With the Revolution, metal frames and parts became popular and had soaring high prices because of the hard labour behind it to achieve the meticulousness. Many craftsmen gave their inputs by crafting windmills and wooden frames, etc. The first big machine tool built was the cylinder boring machine, which could be used to bore the large diameter cylinders on the earlier built steam engines. The planning, shaping and milling machines followed. In the early parts of 19th century, Joseph Bremer, an inventor and locksmith, had patented a lathe similar to that of a slide rest lathe, hired Henry Maudslay to produce high-security metal locks which required meticulous workmanship. Maudslay was a perfectionist in the slide rest lathe, which could perfectly cut screws with various pitches of thread using variable gears between the lead screw and the spindle. Later on, Maudslay set up his own shop and trained many men on this machine. Revolution in chemicals. John Roebuck has been credited with the production of first chemical sulfuric acid, which he did by using the lead chamber process in 1746. He replaced the expensive glass containers with compartments made of lead and produced large quantities around 100 pounds at a time. Production of alkali and sodium carbonate followed, which was produced by Nicolas Leblanc in 1791. He also introduced the Leblanc process, in which sodium chloride was reacted with sulfuric acid to produce hydrochloric acid and sodium sulfate. Sodium carbonate had many uses in industries like soap, paper, textile and glass. Earlier sulfuric acid was used to remove rust from iron and to bleach clothes. Based on the discoveries of Claude Louis in 1800, Charles Tennant made an improvement in the production of bleaching powder. Earlier the process had required months, which he now reduced to days. His factory at North Glasgow had become the biggest chemical factory in the world. Later, in the 1860s, Germans took the lead in producing dye and had many ambitious chemists rush to Germany to learn the procedure. British did not set up any universities as an alternative, just employed German chemists. Revolution in other trades. Cement. A British, Joseph Aspdin, patented Portland cement in 1824. The Portland cement was used to construct the London sewerage system and the Thames Tunnel. Gas lighting. William Murdoch was the person who brought in this revolution, and in London between 1812 and 1820, the first gas lighting utilities were set up. Gas lighting played a crucial role in the industrial organizations, as because of light the factories and other setup could remain open for a long time. Paper machine. Nicholas Louis Robert invented a machine which made continuous sheet of paper, and the machine was named Fourdrinier. This method of paper production is still used by today, although there have been many alterations made to it. Glassmaking. In the year 1832, Lucas and William Chance brothers, first used the cylinder process to make glass sheets. The continuous sheets of glass helped in planning many interiors freely. Agriculture. The main machines that helped in the revolution of agriculture were the Dutch plough, threshing machine, and seed drill. In 1701, a better seed drill was invented by Jethro Tull, but it was an expensive machine. The first marketable plough was made by Joseph Williams, Rotherham, in 1730, and the threshing machine was made by Andrew Meikle in 1784. The threshing machine brought about riots and revolts, as manual threshing required a lot of labour. Many labourers lost jobs and caused the agricultural rebellion swing riots. Transportation. The turnpike road network, railway lines, waterways and canal were all improved because of the Industrial Revolution in Britain. It was now easy to move products, commodities and raw materials speedily, easily and at a cheaper price. Better transportation helped new ideas to spread across fast. Canals. The first canal, Bridgewater Canal in northwest England, was built in the 18th century, and most of the fund came from the 3rd Duke of Bridgewater. Many canals followed soon, and Thames and Severn Canal and Leeds and Liverpool Canal were the most noticeable ones on the list. Later on, Manchester Ship Canal was the largest canal in the world and was inaugurated in the year 1894. Roads and railways. Before the revolution could start, roads were not properly kept, and later on, after the 1720, turnpike trusts were set up to maintain the roads. John Macadam, Thomas Telford and John Metcalfe were responsible to engineer the roads, and they did not disappoint their fellow countrymen. The first steam-run public railways began in 1825 with Stockton and Darlington Railway, and in 1830 Liverpool and Manchester railways were opened for the public. Railways took place in 1829 when hot blast was developed, which lessened the fuel intake of making iron. Social effects. Industrial Revolution was a roller coaster in the lives of those who witnessed it. Although the changes were for good in long term, there are many who suffered the wrath of modern machinery and inventions of various machines and products. The cottage industry was practically applicable in every home, where a farmer and his family mostly produced goods themselves. The spinning jennies were fairly priced and could be afforded, but the products which replaced it were very expensive, and the only thing a man could do was get a job in the factory. The factory labourers were poorly paid. It was not until the late 1980s that the standard of living for the common masses improved. Most of the population constituted of the poorer class, who endured much declines in their standards of living. The wages were increased only by 15% in the late 1780s. Earlier, many died of hunger and malnutrition in France and Britain and on. An average people lived only for about 35 years. This was because of the increasing population with the Industrial Revolution. Things became cheaper and food prices were decreased too. People during these times lived in extremes. Factory owners had beautiful houses, whereas the labourers of the factories did not even have a proper enclosed home, which lacked sanitation facilities also. People shared small rooms and slept on sawdust. Unhygienic situations gave rise to many diseases, and there were many diseases that were caused by water, like typhoid and cholera, were common among the children. Conditions improved only in 19th century when many health regulations were followed and conditions improved. Industrialization beyond United Kingdom. Belgium. Just after the Industrial Revolution in Britain, continental Europe also lined up with their inventions and creations to bring about a revolution. Most of their ideas were borrowed from Britain, and a part of Ruhr Valley in Westphalia got the name of Miniature England because their inventions were same as that of the English. In many situations, only some parts of the British inventions were adopted as their locally available resources were different than the English. There were many mining areas built in Liège and Charleroi, and John Cockerill set up a factory in Suresnes which had all the processes from production to supply. Historians have also stated about many developments on iron making as well, especially in Sambre, Haine and Meuse valleys. The revolution was considered to be quite traditional and didn't quite affect most of the population except for those areas which were situated near the coal mining and iron making areas. United States of America. While other countries were experiencing industrialization, America continued to be an agricultural economy. Railways, roads, waterways and canals were important to move the agricultural products and the natural, especially in such a huge but thinly populated country. America saw industrial revolution with the invention of cotton gin and a method of making interchangeable parts. The invention of machine tools and the way of making interchangeable parts lay foundations for the Industrial Revolution. Oliver Evans made an automatic 4-mill which required absolutely no labour from the time of loading the grain to the flour discharge. Later, in 1787, Cabot Brothers and Thomas Summers found the Beverly Cotton Manufactory, which was the biggest cotton mills of the time. The American Industrial Revolution was set on the banks of the Blackstone River and its tributaries, and around 1100 mills functioned in this valley. In 1854, Waltham Watch Company, situated in Waltham, in Massachusetts, was recognized to bring industrialization in the watch industry. Samuel Slater set up the Slater Mill in 1793. He mastered his skills from Derbyshire in England and moved to New York in 1789 by breaking the British laws of the emigration of skilled workers, where he later owned 13 textile mills after he founded the Slater Mill. Germany. The Germans were wonderful chemists and they flourished in their chemistry. People flocked from all over to study in their universities and learn the new ways of dye. Earlier, because of lack of unity among them, the Germans lagged behind in building efficient roads and railways, but Britain's quick development buckled them up and they were soon constructing railways and roads. Sweden. Sweden experienced two revolutions simultaneously, agricultural revolution and industrial revolution. They had large estates, new farming tools and crops, and developed a system of proto-industrialization where the farmers could grow their crops, and when they were free after the harvest in the winters, they could move to the industries to earn wages. The Industrial Revolution focused on their local markets, which circled on paper making, textiles, mechanical engineering and power utilities. The country prospered with trade and commerce when they opened the gates for free trade and exported wood, steel and crops. Japan. The leaders from the Meiji period helped in bringing about an industrial revolution in Japan in 1870. They sent thousands of youngsters to Europe and United States to learn their ways and employed over 3,000 experts from Western world to learn their language, technology, mathematics and modern science. The Iwakura mission of Japan was a breakthrough in their revolution, and Japan quickly caught up with the others. In 1882, Bank of Japan was founded and used taxes to set up textile factory and model steel. Japan's first modern industries came up in textiles, which comprised of cotton and the famous silk. Silk was made in many workshops which were at home, mostly in the rural areas. The history has experienced much turmoil and Industrial Revolution has contributed much to it. This phase saw the most intelligent of people who set base to modern machines, tools and techniques that we use. Historians have varied opinions about the Industrial Revolution which cannot be summed up easily. Capitalism was caused as when science was on its boom and developments which brought about an upgrade in the society as a whole. The machines helped the people to work with ease and provided jobs to everyone in the factories, which led to increase in wealth, and only the adults worked while the children and adults were free. Socialism came up as an evaluation of capitalism. According to Karl Marx, Industrial Revolution divided the society into two. Bourgeoisie were who possessed the means of production, the land and the factories, and the other were proletariat, the labourers who performed the work in the factories under the bourgeoisie. He saw the industrialization procedure as the rational dialectical development of feudal economic modes, essential for the complete growth of capitalism, which he saw as in itself a required predecessor to the growth of socialism and ultimately communism. The debate can be endless, however, it can be concluded by saying that Industrial Revolution was a significant era and mankind is still evolving with those basic principles of inventions which took place during that period.